Since the Model T first came off the assembly line in 1908, automobile manufacturers have been trying to engineer a faster, easier, more efficient way to make cars. A lot of cars.
Fast forward 100 years, and you'll be amazed at how their efforts have paid off. Here at Hyundai Motor Manufacturing in Montgomery, Alabama, engineers have designed one of the most advanced assembly lines in North America. It's a joint effort between 3,300 employees and over 500 robots. Together, they crank out more than 1,000 cars a day, including their premier midsize sedan and SUV.
So this is the start of the auto production process. It's a stamping plant.
Okay.
And what the stamping plant does, it produces all your outer skins and your inner metal part.
It's here where a single 44,000-pound coil of steel begins its journey to becoming up to 110 car bodies. First, the continuous sheet of steel peels off the roll onto a conveyor belt. The conveyor belt then feeds the steel into a machine called a blanking press. This cuts the steel sheeting into cookie-cutter shapes called blanks. Blanks are used to create each of the car's 17 exterior body parts, including the door panels, roof, and trunk. But it's the next step that turns these blanks into recognizable car parts. Behind these closed garage doors, two stamping presses apply 5,400 tons of pressure to form or stamp the flat blanks into three-dimensional parts. And they can stamp as many as 12 parts a minute. That's over 11,000 parts each day. Once the stamping press completes a part, it sets it on a conveyor belt, which carries it to these, the palletizing robots. These robots use vacuum-assisted suction cup fingers to pick up the stamped parts, then load them onto pallets or movable storage carts. But this is nothing compared to what's next. Welcome to the future. This is the welding shop, also known as the body build area. It's a sea of robots, 275 to be precise, that fuse together many of the stamped parts of the car.
This area here is where we assemble all the hoods, deck lids, and doors for the final vehicle.
Some of these robots are enormous, standing 7 feet tall and weighing 2,000 pounds. Here, one robot picks up an external door panel, while another one places an internal panel on top. Then, this robot welds the two pieces together. Finally, it lifts the completed door and carefully places it onto another pallet. Then it's off to the main buck. The main buck holds the car's left, right, top, and bottom sides in place, while the robots weld each of the pieces together. These robots perform their tasks to within 1/1000th of an inch. The entire process takes less than a minute.
So it's really starting to look like a car now.
Marshall, we're now at the end of the actually body build process. We've got the shell of the vehicle, 6,000 welds later.
6,000?
Yes, sir.
And who do you think checks the accuracy of the welds? Other robots. These robots take pictures of 50 key points on the automobile frame and compare the welds to a computer model. The welds must match the model to within 1/2 of a millimeter. If a frame doesn't pass inspection, it's bumped off the line and sent back for more welding. Frames that pass inspection take the high road over to the body complete area, where they're outfitted with doors, a hood, and a trunk. And now it's ready for paint.
Holy, look at, it's like picked up the entire car.
Marshall, this is what we call the E-coat or electrocoat system.
E-coat is an electrically applied undercoating that protects a car from corrosion. Workers pump up to 300 volts of electricity through this liquid while grounding the car's body. Because opposite charges attract, the undercoat adheres to every square inch.
Why the rolling?
By rolling the car, any dead airspace, any trapped airspace is going to be rotated through, and we're going to have good, even coverage of E-coat throughout the body.
After the car bodies exit the electrocoat bath, they travel down another trestle into the first of many painting rooms. For the next 9 hours, the cars will move down 4 miles of a conveyor system, lined with 98 painting robots. Here, they're spraying a coat of primer. Next, they cover each frame with one of 15 different paint colors. And finally, they apply a clear coat that provides shine and protection to the vehicle.
What's the river that's flowing underneath? Like there's metal grates and you can look down, you can just see a river of water flowing. What is that doing?
The purpose of that system, of course, we have a very high transfer efficiency, which is the amount of paint that we spray out that gets on the car. It's about 95%, but that means 5% of it does not get on the car and it has to go somewhere. So that is driven down through the grates by what we call downdraft.
These air filters send a constant stream of air from the top of the booth to the bottom.
So the entire ceiling is a giant duct
That's exactly right.
shoving air downward to pull all the particles of paint out of the air.
That is correct. It then is captured in water, and then that water is sent to our facility where we extract the paint out, and then that paint is disposed of.
The next stop is the trim assembly shop, where man and machine finally come together. Here, workers install wires, brake controls, and other parts inside the car and under the hood. And take a look at what these cars are riding on.
As you can see here, we have the skillets just underneath the car. See the part that's raising?
orange part.
The orange part with the
Okay.
bellows. These are called skillets, and what they do is they raise up and down, and the equipment actually works with the team members so that they can get a better perspective of the job they're doing.
These skillets are another example of how far the assembly line has come. Each one carries an individual car frame through the assembly process, moving not only forward, but also up and down. This range of motion allows for quicker installations and for workers to stand up straight rather than bending over all day. It's an important feature of this assembly line where people, not robots, do most of the work. But robots still play a role. This is one of the employees' favorites, the cockpit module robot. This machine installs the entire cockpit or dashboard into the car.
This is our cockpit module and robot. It actually locks into the skillet so that it can track with it, and it'll actually come over to the car and it'll take a picture of the brackets inside the car.
So when that light turns on, it's optically looking at the holes in the side of this cockpit.
Yeah, so when it shoots that light, it's actually taking a digital photo of the brackets on the side. And then that tells it, hey, these brackets are in line, I can install the cockpit.
Next, the cars move out of the trim area and into the chassis area. The chassis is the frame that supports the car's transmission, exhaust and suspension systems, and engine. It's here that workers finally marry the chassis to the rest of the car's body. That flies in on an overhead conveyor system.
This is unbelievable. So what is this car that's driving along on the ground?
These are called AGVs, or automatic guided vehicles.
These automatic guided vehicles gently move the chassis and all its parts directly underneath the car's body.
It's amazing, actually. And what keeps it aligned with the monorail that's overhead?
What we've got is we've got sensors in the floor that the AGVs will actually have antennas underneath them that read what's on the floor. And then in the overhead, we actually have sensors in the overhead that tell the overhead conveyor where each carrier is at.
Okay, and the computer just lines them up and keeps them synchronized.
Exactly.
So by the time we get through this section, what has been accomplished?
By the time we get through this section, you have pretty much what you would consider a rolling car. You can actually put tires on it and it would roll around.
In a moment, Marcia will turn the key for the very first time and see how well this new car actually performs. And later, this may look like a car wash, but you're more likely to eat this stuff than drive through it. Here at Hyundai in Montgomery, Alabama, we've just seen the body and the chassis of this sedan come together. Now it's time for the car to move into final assembly. Here they install components such as the seats and tires. And they've got to keep up with the clock.
So this is happening pretty fast. How does this compare to a pit stop or something in a race?
Well, pit stop in a race is about 14 seconds. These guys actually have 49 seconds to do their job.
Once workers attach the remaining parts and add some gas, there's only one thing left to do.
So this is actually the first time the car is going to get started. So go ahead and fire up.
All right. Look, we're ready to go.
Once an engine turns over, a worker drives the car into the final evaluation area. Here, a team of technicians tests the brakes, headlights, and air conditioning system. And then, it's finally time to put the pedal to the metal. Nearly every minute, a new car exits the general assembly area and drives onto the 2.3-mile test track. Here they challenge the car to some worst-case scenarios.
Now, this is exceptionally a rough road. Now, personally, I've never seen roads quite that bad.
It'd be rare. We accelerate and we do our S-turn.
Oh. Those are rather aggressive S-turns.
They sure are. Stop here and we'll in reverse.
So, you never get car sick?
That never bothers me.
I can see that.
So we'll accelerate to 70 miles per hour. Listen for wind noise.
After about 10 minutes of rigorous road testing, the verdict is in.
So, do you feel confident this car is ready to go?
Oh, yes, I do. And we'll check our alignment.
In less than 16 hours, they've transformed a coil of steel into this, and this, and this. Today, Hyundai produces over 1,000 cars every 24 hours, just from this facility alone. And it wouldn't be possible without a little help from these guys.